Welcome to Climate Now. I'm your host, James Lawler. Our regular listeners may notice that today we've got new music. Well, it turns out that one of our guests, Chief Technology Officer of the company Moat Hydrogen, Josh Stolaroff, is also an accomplished musician. And he was kind enough to give our jingle an overhaul. Josh, thanks again. In this week's podcast, we're exploring a pioneering method of carbon capture and storage that addresses one of its biggest hurdles, the cost. For those joining us for the first time, Climate Now is a multimedia platform that provides expert-led insight into the technologies, methods, and theories that underpin the global transition away from fossil fuels. You can visit our website, climatenow.com, to find full transcripts of our podcasts and to browse our videos, which provide comprehensive overviews of key climate and energy topics with the help of leading experts and illustrative charts and graphics. You can also subscribe to our in-depth newsletter, which we call Systems Thinking, where we analyze important trends and ideas, from energy efficiency to decarbonizing road transportation and many more. As always, if you find the conversation today useful, share it with a friend or colleague. And if you have notes for us, please email us at climatenow.com. We love to hear from our listeners. On this podcast, we have had several conversations about the need to not just reduce carbon pollution, but to actually remove carbon dioxide from the atmosphere through carbon dioxide removal, or CDR, techniques like carbon capture, storage, and utilization. The biggest obstacle to using carbon capture and storage on a large scale is its cost. But today we're going to discuss one form of the technique that could not just make carbon dioxide removal affordable, it could make it profitable. It involves taking carbon-rich waste biomass, which is leftover wood from forestry, yard clippings from landscaping, scrap wood from construction, that sort of thing, and turning it into energy and storing the leftover carbons safely underground. The method is called Bioenergy with carbon capture and storage, or BECCS for short. Just to throw another acronym into the mix, because let's face it, who couldn't use more acronyms in the climate space? There are a couple of variations of BECCS. One of them is BICRS, BICRS, which stands for Biomass Carbon Removal and Storage, which is more associated with biomass to hydrogen with carbon capture and storage. And that's the kind of BECCS we're going to be talking about today. But anyway, in this episode, I'll speak with the minds behind two BECCS projects that are currently in development in California. First, John Kusel, founder of the Sierra Institute, and carbon capture scientist George Peridas from the Lawrence Livermore National Laboratory have developed a project in the Sierra foothills that aims to help California meet its carbon reduction goals while also protecting local communities and ecosystems. I'll also speak with Josh Stolaroff of the company Moat, which is a Los Angeles-based startup that produces clean hydrogen fuel from biowaste. In our conversation, we discussed the real-world economics of a hydrogen-producing and carbon capture storage technology that could be a win for the planet, people, and profit margins. First, let's do a quick overview of carbon capture, utilization, and storage. If you want to learn more, you can check out our podcast episode Carbon Capture 101 with Howard Herzog, or our two-part video series on the technology, cost, and potential of CCUS. But for now, the thing to keep in mind is that on the spectrum of carbon dioxide removal strategies, carbon capture is among the most complicated and expensive, but also the most secure. You can think giant towers of fans pulling in air and filtering out the CO2 and pumping that CO2 deep underground where it'll be securely stored for thousands or millions of years. While other techniques are more simple and inexpensive, like planting a lot of new trees, for example, that naturally remove CO2 from the air, they don't offer that security. All you need is a forest fire or a pine beetle infestation, and all that trapped carbon is right back up in the atmosphere. George Peridas has spent his career researching carbon capture techniques. He joined the Natural Resource Defense Council in 2006, and he is now with the Lawrence Livermore National Lab. In our first conversation, he explained why carbon capture is more important today than ever.
I think what has happened since 2006 is a much deeper realization of how deep a trough we're in when it comes to climate change. I think the speed of change that we could witness in the natural world has really picked up. With it, I think has come the realization that we are simply not moving fast enough in the action space and in the policy space.
But carbon capture faces a number of challenges. Some methods are still largely theoretical. Others are too costly. One of the most popular carbon removal methods involves capturing CO2 directly from coal or gas-fired power plants before it can escape into the atmosphere, but some critics argue that that approach gives the energy industry an excuse to delay a full transition to sustainable power. One challenge almost all carbon removal methods share, though, is that while they provide a service, they do not actually make a product. And until the world is ready to pay up for an atmospheric carbon cleanup service, these methods do not generate enough revenue alone to offset their costs. However, George Peridas believes that BECCS, bioenergy with carbon capture and storage, could be an exception. He has partnered with Jonathan Kusel and the Sierra Institute, a California-based nonprofit, on a new project that aims to take waste wood from forestry, convert it into clean burning hydrogen fuel, and store the excess carbon safely underground. I sat down virtually with Jonathan Kusel and George Peridas to ask them how that works. So Jonathan, let's start with you. What is the name of this project? Does it have a name?
You can probably criticize me for us not coming up with that sexy title yet, but at this point, it's the Indian Valley Wood Utilization Campus.
And George, how did you and Jonathan come to be working together? What are you collaborating on?
So there are several converging elements and trends here. California faces, in particular, several problems at the same time. It has very ambitious climate goals. It aims to be carbon neutral no later than 2045. It has been plagued by catastrophic wildfires, and the problem seems to be worsening. It has an economy which has been, for some time now, quite heavily dependent on fossil fuel extraction and use. And it's looking for ways to transition away from that economy. So we have many problems to solve at the same time. Where Jonathan and I came together and met is that we discovered that we can kill several birds with one stone. And in particular, the idea of not just being carbon neutral, but actually removing CO2 on a net basis from the atmosphere. Being carbon negative can also be done at the same time as benefiting local communities, improving their air quality, and also reducing the risk of catastrophic wildfire and their severity if they do happen.
Jonathan, tell us about the current state of this project and also of this technology that George is describing. How far along are you with this effort?
California is investing now billions into landscape. But what's not well understood, or I should say is increasingly understood, is that if we don't figure out what to do with some of that material, we're not going to be successful at addressing the landscape problems that we do have because of the scale and the volume of material that needs to come out of our forests. I'm not talking about industrial forestry that mows down landscapes, which is not to say all industrial forestry does that, but it is to say this is not about removing all this material. So we can not only just take that material, turn a turbine, make electricity, which is an effective use of it, but we can take that material and through a gasification process, we can turn it into hydrogen to address exactly what George was alluding to.
And so what part does the Sierra Institute play in that equation?
By purchasing this 28-acre mill site, we're creating a place where that work can actually be done. That is the conversion of biomass to hydrogen. What we've also learned is that when one takes material from the forest, it's really important to try to, quote unquote, add value to it. Biomass itself has very low to no value. That is, it costs a certain amount of money to thin the forest, it costs some more money to transport it, and then it costs some more money to utilize it. So if you can produce products from that material, now you're way ahead of the game with the idea of creating a loop in which you produce something more valuable that then can be reinvested back into the landscape. So we're creating this cycle of creating product and adding value to that product such that it can then support additional restoration practices.
Maybe you could paint a picture of where are you in the process with the project? Like, what is the status? Has any of the infrastructure been built on this plot yet for this gasification process, or is it just the plot of land that's been built?
We've done a variety of assessment efforts and remediation efforts on site. Step one was getting the site, but we had to do that to understand the liabilities associated with it. So they went together. Two, continuing to develop the site in ways that allow for these sorts of technologies to be advanced on site. 3, we're working with Forest Service, Plumas National Forest, Lassen National Forest, Region 5 of the Forest Service to develop contracts to help assure a supply of material, because what anybody who wants to invest in a facility like this will say, well, I don't want to put up $50-100 million only to see 3 years from now there's no supply.
Right.
And then it's a stranded investment. So we're working to assure that those contracts are in place, that there's confidence that we'll have that material. One of the ironies here is that as we have fires like the Dixie Fire, like the fire in Peridas, like a lot of these other fires, we're creating material faster than we can possibly use it. Nonetheless, we still need to make sure that there are contracts in place. And so we're very close to working with the Forest Service, where some of this work is absolutely essential to assure the supply to launch a facility like this.
How much biomass do you need to deliver per year to this facility, out of curiosity?
90,000 to 100,000 tons per year.
And George, from your perspective, what does success look like for this project?
There's nothing more compelling in my view than having a real facility that's on the ground that does all the things that, you know, these reports and studies identify. There's no arguing with a real project. You go over to visit it and you see it, and it's doing what it's meant to be doing. I think what's particularly attractive or exciting to me about this project is that this is a unique opportunity for us to demonstrate that what's good for the climate, it's also good for local air quality, it's also good for community welfare and economic well-being. This is a unique chance, if you ask me, to demonstrate that we moved away from the paradigm of the past, where certain types of project or development were put in place to serve the whole, but actually had a negative impact on a local minority.
I'm wondering if there's a back of the envelope kind of narrative that you could tell us regarding the sort of proposed economics for this operation. You have the hydrogen that you're producing that someone's presumably going to buy. You've got these other products you alluded to in terms of other uses for the burnt wood. Is there a kind of revenue model that you've worked out or that you're sort of aiming for?
In a grossly oversimplistic way,
yeah.
Does the darn thing work, and can we pay for it?
Yeah.
And then can we purchase chips? But in more detail to your answer,
yeah.
We have talked about a payment per ton of biomass. And biomass, as I mentioned previously, has low to no value. It does not pay its way out of the woods. Back to our point. So is there a state and federal benefit to this kind of project? And the answer is absolutely yes. If what we can do is generate something that pays $50 to $55 per ton of biomass, now we're paying for some of the restoration. And we're not just looking for subsidy to do that work on the landscape. So there's a very direct relationship by setting up these facilities. This is to the point of, if we can invest in these facilities, create these opportunities, that's essential for us societally being successful in restoring our landscapes. Without a place to take material, that will buy material, that will pay for material over time, we will not be successful. So the model then is, can we pay enough for the biomass to get it out of the woods? And then is there a market that will pay for that product, like hydrogen fuel with the carbon credits that are associated with it? That's a viable model, as we've done the back of the envelope, actually much more detailed than that, as we've looked at the economics of it.
So to summarize, the Sierra Institute is working to take each year 90 to 100,000 tons of waste from necessary forest thinning and convert that biomass into hydrogen gas and carbon dioxide. The hydrogen gas is a fuel that can be sold for a profit, and the carbon dioxide formed from all of that carbon that was in that wood could be sequestered safely underground. Jonathan said the project will require at least 50 to 100 million in investment, but he and George are confident the project will be profitable, will help protect people from wildfires, and will help the state of California reach its carbon reduction goals. It's what they call a triple bottom line model, i.e. a win-win-win for the climate, local communities, and investors. But let me take a quick pause to explain why hydrogen is important. Hydrogen is a combustible fuel, but it's extremely clean burning. In fact, when you burn hydrogen, the main byproduct is water. The problem is that pure hydrogen doesn't occur naturally as a concentrated and mineable resource. You have to manufacture it, and that process uses a lot of energy to pull the hydrogen out of more common hydrogen-bearing compounds, like water, organic material, or fossil fuels. BECCS projects extract the hydrogen from wood and other biomass, but the process releases CO2 as a byproduct, which then needs to be captured and stored safely underground. This gasification approach is relatively new in the world of carbon capture, but the Sierra Institute aren't the only ones developing it. Here's Dr. Josh Stolaroff, Chief Technology Officer of Bioenergy and carbon capture startup Moat, explaining how that works.
So waste biomass includes agricultural residues like orchard tree trimmings, nut shells, fruit pits, and those are important feedstocks for our process. It includes forest residues like from fire management. They clear brush and small trees, and it can include urban green waste, so like yard trimmings, pallet wood from construction and construction and demolition debris. So to gasify biomass, you feed it into a vessel where it gets heated with a limited amount of oxygen. If you heat it up to, let's say, 400 degrees Celsius or 800 degrees Fahrenheit, you get pyrolysis. So you turn it into other forms of carbon, and you can make liquid fuels that way. You can make biochar that way. But if you keep going up in temperature up to 1500 Fahrenheit or 800 Celsius, that kind of range, then everything turns to gases. And so that's gasification. So we end up with hydrogen and carbon dioxide as our outputs. And there's some ash. And the ash we can sell as a fertilizer additive. Hydrogen we sell for transportation, and CO2 we put underground for geologic storage.
Like the Sierra Institute, Moat is based in California. Before officially joining the company, Joshua actually spent 11 years at the lab where George Peridas is based, Lawrence Livermore National Lab. He helped create their carbon capture program, and he and his colleagues later consulted with the state of California to help it define strategies for meeting its net zero goals. Joshua said after extensive research into various carbon capture methods, BECCS stood above the rest for both cost and efficiency.
We did an analysis, and it became the report called Getting to Neutral about the carbon removal options in California. And we built a supply curve. We kind of said, here are all the things you can do that are less expensive, like natural solutions, on up to the most expensive things, which were direct air capture. In the middle, it turned out there was a huge portion of options that were using waste biomass to remove carbon, but also make other things. And biomass gasification to hydrogen was one of the pathways that we looked at. We also looked at biomass pyrolysis to liquid fuels and hydrothermal liquefaction of biomass and burning biomass to make electricity, all these options. And it was a surprise of the report that biomass gasification to hydrogen with carbon capture was the best. It turned out to be the best in terms of the amount of carbon you could remove, the cost you could do it at, and the fossil fuel emissions that you avoided by making renewable hydrogen instead of fossil hydrogen.
And then with the hydrogen piece, so you're also selling the hydrogen. So that's being purchased by the transportation industry or would be purchased by transport. What would the applications of the hydrogen in transport and how developed is that market today in California?
The market for hydrogen as a direct transportation fuel is also new in California. There are hydrogen stations out there, and you can buy hydrogen cars, and that market is growing rapidly. So we think actually the bigger market in the long run is going to be heavy duty trucks and transit like buses. So we plan to sell the majority of our hydrogen for heavy duty filling stations, but there are a lot of other uses of hydrogen besides that.
What about other applications like other industries, harder to abate sectors like shipping or steel making? Do you see promise for hydrogen in those arenas?
Yeah, I think hydrogen can be really important for steel making.
Mhm.
It's crucial for fertilizer, ammonia production. And I think another area where it's really useful is as energy storage for electricity production.
Mhm.
So, in California, we want to go to a carbon neutral grid. As a country, we want to go to a carbon neutral grid. You can theoretically do that with all renewables and batteries, but it's very expensive. And a lot of recent reports where they model out what happens when you have 100% renewable grid show that it's expensive because the batteries are expensive. It's expensive because you need to build a lot more wind and solar to make up for the gaps in supply, and it takes up a huge amount of land.
Mhm.
And if you had some baseload power or some dispatchable power in there, it drastically reduces the amount of land you need, drastically reduces the cost of the system.
So you formed your company and you are the chief technology officer there. What does that entail at the moment? Where are you currently in the build out of this company and your operations?
Moat today is a startup company. We have 6 people full time, and we're moving toward deploying these facilities that turn wood waste into hydrogen and CO2. So what we've done in the last year is we've done the initial phase of engineering for the first project. We've developed some of the intellectual property around how you do that, and it's the design for the facility, how you put the pieces together to achieve this goal. And we talk with customers, we talk with investors, we talk with technology vendors to put together projects and put together the pieces of the technology that can make it happen.
And do you have a facility that's up and running yet? Or you, I assume, no, you're looking for investment so you can build one?
We have the preliminary, they call it the preliminary front end engineering design for the first facility. So the next step would be the front end engineering design. So kind of the more detailed phase of engineering. And then we would seek project investment. We would go to funders and say, here's our plan, the economics of it work out this way, loan us $300 million or give us part of that package to build the plant.
In terms of the inputs, how easy is it currently to get up and running and supply oneself with a stream of biomass?
There's a lot of waste biomass out there. And so there are tens of millions of tons in California, hundreds of millions of tons in the United States. But getting it for a bioenergy project is a process. It's a personal relationship driven business. As you might imagine, the suppliers are farmers, they're municipalities, they're foresters. And so you need to deal with a lot of small players, and you have to have a strategy for putting together a supply from a bunch of different sources and making it reliable.
The picture that's in my head is somebody in a truck just going around to all these farmers and saying, "Hey, do you have anything anything you can throw in the back here?" Going up to forests and sort of rummaging through and pulling out big logs. Obviously, that's not the way that this this needs to work.
I'll say it is more organized than that. The companies that pick up biomass from farmers that are ag residues, they have long-term contracts, and they have equipment that they have to invest in, multi-million-dollar equipment for processing and transporting biomass. In California, there's a well-developed network of biomass supply, and it's been
Mhm.
driven by bioenergy plants that are operating or have recently operated, and rules about landfill biomass, or you soon won't be able to landfill waste biomass, and you soon won't be able to field burn agricultural residues.
And then on the output side, you've got hydrogen, CO2, and the ash. Where does the CO2 go? Is it compressed CO2, and who are the buyers of that?
Primarily with CO2, we put it underground. So we partner with companies that are doing geologic storage. And in California right now, those are mainly oil and gas companies. And they have the expertise and the land and projects to do CO2 storage from other sources. And so we piggyback on to those projects, and we pay them a fee per ton CO2, and they take the CO2 and assure that it stays underground.
What is the going rate for hydrogen, average going rate in the marketplace if you want to buy a ton of hydrogen?
Yeah. So if you go to a filling station in California today, you'd pay around $15 per kilogram of hydrogen, which is actually pretty expensive. Although as expensive as gasoline is right now, it's kind of on par. We think that will come down over time.
So what does that look like in terms of cost profile? It sounds like that's pretty good then, right?
Yeah. No, economically it works out. And it's because hydrogen is valuable and carbon removal is valuable. And there's a lot of carbon in biomass. As an energy carrier, there's per unit weight, it's not great compared to fossil fuels. So coal has like twice the energy per unit weight that wood chips do, and coal is not even that great. So for a long time, biomass was thought of as kind of a marginal energy source. But when you think of it as a carbon carrier, it's half carbon by weight, and it's carbon that the plants took out of the air. So that's really inexpensive carbon removal compared to industrial means like direct air capture. And it's putting those value streams together, the carbon removal and the hydrogen production, that makes Moat's process work.
When an organization like Moat or the Sierra Institute creates hydrogen fuel from biomass, it doesn't just manufacture a product. It also provides the service of carbon removal. And Joshua says the number of revenue sources for carbon removal is growing. The federal government provides a tax credit for carbon removal, and there are state-level incentives, like the California Low Carbon Fuel Standard, which provides financial incentives for using and producing low-carbon fuel. There is also a growing private sector market for carbon removal and offsetting, as more companies try to reduce their own emissions. But the growing market for carbon removal might actually present a challenge for projects like the Sierra Institute's Indian Valley campus. During my conversation with George Peridas and Jonathan Kusel, I asked about the potential scale of their project. Jonathan explained that in their case, bigger does not necessarily mean better.
So the economics are such that most investors would prefer to go to 400 or 500,000 tons per year, but when you build a facility that's 4 and 5 times larger, you impact a local area that much more. You also go beyond the capacity of the nearby landscape, so you're hauling from further and further distances to bring in that material. So we're trying to scale this with the available technology that works at an appropriate economic scale, but that also can be served by that nearby landscape to avoid 100-mile, 75-mile, 60-mile haul distances. So we reduce the carbon impact just in terms of sourcing material. And then that it is also tied to workforce capacity, which is why we talk about community scale and the importance of that. And that's a challenge in lining up the economics with the reality of the industrial operation and investor interests in advancing something like this.
Basically, there are a lot of stakeholders and different interests at play when you are trying to remove biowaste and produce an energy supply and capture and store carbon. And there is a lot of room for skepticism. George pointed out that even some in the climate movement are wary of carbon capture, especially methods that capture emissions directly from coal or gas-fired power plants. They fear it could give the industry an excuse to delay a full transition to sustainable power.
They've created this association between capturing carbon and some of the fossil fuel companies that in their eyes are the arch enemies. I think the best way to describe it is wanting carbon capture to be tomorrow's technology forever. The promise of something cleaner as a way to legitimize what you're doing today, when it's clearly incompatible with human, environmental, and climate protection.
Joshua Stolaroff also pointed out that BECCS and carbon capture methods in general are still relatively new, and the industry still depends on government incentives. Again, the revenue model of the projects of Moat and the Sierra Institute both rely on state and federal tax credits. Joshua says those incentives may be strong now, but the industry can't take them for granted.
And this is the same challenge that any carbon capture and any climate mitigation technology has, is the time we have to scale it is short. And the challenge that carbon capture has had in the 20 years that I've been working in it for a long time was that there weren't incentives in place to make people do it. That we waited a long time to have the state and federal policies that would incentivize carbon capture. And I spent a long time at a national lab trying to make carbon capture 10% less expensive so that hopefully some policymakers would think that it was worth putting an incentive in place. And it was only in the last few years that we turned around and saw that the incentives are there, that you could do carbon capture and storage with the existing frameworks and make a business out of it. So that part is really exciting, but it also means that the policy environment has to stay strongly supportive of carbon capture. It is totally possible that if the incentives weaken or disappear for a couple of years, that the industry would be set back another decade.
That being said, Joshua, Jonathan, and George believe in the future of BECCS, the hydrogen market, and carbon capture in general, and they are committed to helping the industry develop one log and wood chip at a time. With BECCS, they have found a carbon capture strategy in which social acceptance and profits have a good chance of both being part of the mix, two aspects of most carbon capture and storage endeavors that so far have remained stubbornly elusive. That's it for this episode of the podcast. To learn more about carbon capture, utilization, and sequestration, check out our interviews with Howard Herzog and Julio Friedman at climatenow.com. There you can also find 2 videos on carbon capture, where we go deep into the costs and potential CO2 storage capacity of these technologies. And if you want to get in touch, please do email us at contact@climatenow.com. We hope you'll join us for our next conversation.